Hello everyone. Today in this video we are going to learn applications of matrices. Where we can apply matrices. Applications of matrices. Everywhere in our day-to-day life we use matrices. For example, in day-to-day life, so let's take a classroom. In classroom, if board stands here, how children's seating arrangements are made. Here one bench is arranged, another bench is behind like this, another bench is behind like this, or else I am taking this another way. I am placing board here. I am placing benches in 3 benches in one row, another 3 benches in another row, another 3 benches in another row. Here I am standing and I am teaching you. Here children are sitting. So how many rows are there here? This is one row. This total is one row, right? This is one row. So this is one row. This is second row, right? And this is third row. So in how many columns they are sitting? This is one column. So, and this is another column. And this is another column. So this is one column, first column, this is second column, this is third column. So this is how we represent a classroom in a matrix. Let's take this in numbers. This is what is the order of this matrix? There are 3 rows and 3 columns. So here how many children are sitting in the third row, or else will come from upper side to lower side. Upper side I am taking, this is first row, this is second row, this is third row. So that means screen is this side. Or else if you take movie theater example, there also the screen is that way and seatings are arranged in this way. So in the first row, how many columns are there? 3 columns. In the first column, 2 seats are there. In the second column, 2 seats are there. In the third column, 2 seats are there. Now come to the second row. In the second row, in the first column, how many seats are there? 2 seats are there. Here, again, I am introducing another seat here. I am introducing another seat here. I am introducing 2 seats here. So here, in the second row, second column, 3 seats. second row, third column, 3 seats. Third row, first column, 1 seat. Third row, second column, 3 seats. Third row, third column, 4 seats. So this is how, if we can deduct this number of data into simpler form by using matrix. This is for this order is 3 by 3. So we have to find the easiest way to solve the most complicated problems. For that, matrix got introduced. Like linear equations, there are like 1079x plus 1100 y is equals to 89. So we don't know this. We don't know the solution. So to find the solution for this in systematic way, it will take much time. But if you try to solve this using matrices, it will be very easier. So how we represent this in matrix? Another example I am taking, 90x plus 40y is equals to 62. So how we can represent this in matrix? So here I am taking x term, here I am taking y term is equals to, here I am taking this constant term. X terms is what is here? 1079. Y terms is 700. In the another one 90. Another this y term 40. I'm closing this. And I'm putting constant term 89, 62. So this is how we can represent a linear equation in the matrix form. Again, and the one lively example is playing chess. Matrices in chess. How we can say that? How chessboard is designed? In chessboard, there are 8 horizontal, 2, 3. I'm drawing chessboard here. How matrices works in chessboard, I'm going to explain here. 1, 2, 3, 4, 5, 6, 7. I'm taking this one. 8. So in chessboard, there are 8 rows and 8 columns. So you can say chessboard is 8 by 8 matrix, right? This is 8 by 8 matrix. Order is 8 by 8 chessboard. So 8 columns I have to divide. 1, 2, 3, 4, 5, 6, 7 and 8. Here what I am taking here, A11, here A12, here A13, here I am placing the positions of these boxes, 14, A15, A16, A17, A18. This is in second row, right? So this A21, first column, A22, A23, A24, A25, A26, A27, A28. So This is for black. Now for white. For white, what will be this one? I am taking this as B, B11, B12, B13, B14, B15, B16, B17, B18. Next, B21, B22, B23, B24, B25. I'm comparing pawns with B21, B22, B23, B24 and comparing powers like horses and king, all this with B1. I'm putting all the powers in first row from the downward in the B side. Again here in the A side, I'm putting powers in the upper row and pawns in the second row. So now this B26, B27, B28. So from with this we have to play chess, and there are certain standard rules are there, and we have to use those rules, and in this matrix only. So this pawn can move one place or two place. That means it can go to third row. This A25 can go to third row in fifth column or in the fourth row in the fifth column only. This pawn A2 position, A2 can shift its position to A35 or A45. Here B25, it can move from B25 to B35 if you come back from this side. So I am taking this side as one column, second column, the second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row. This is first column, second column, third column, fourth column, fifth column, sixth column, seventh column, eighth column. This pawn can move B2 to again. Now if you take from this side, this will be first row, this is second row, this is third row, this is fourth row, this is fifth row, this is sixth row, this is seventh row, and this is eighth row. This is from B side and this is from A side. So if B can move B2 to B can move to third row and second column. B can move to here also. B can move to fourth row in second column only. Pawn. This pawn can move only in the front direction in 3-2 or 4-2 only. Let's take horse. This horse can move in L direction. L direction means if this is horse, 1, 2, here this is, it will come. It comes from here also. Again, this queen can go to cross direction. Cross direction means what matrix it is framing? It is framing a diagonal matrix, right? It is a diagonal matrix. It is forming diagonal. So in the formation of diagonal, so whatever place it will face, whatever power in this place, it will take this queen, it will queen will take that pawn with that power and move on. So that is the power of queen. So in this how we can easily learn chess by using matrices. So another example, in technology. In technology, how we use this matrix? Like chessboard is order 8 by 8, right? Eight by eight. So if you want to take a matrix 6 by 6 from 8 by 8, so what we will do? We just draw 6 horizontal and 6 vertical and 6. 1, 2, 3, 4, 5, 6. But there are 8 in the chessboard, right? So how much is left? Left we can show with black pen. This concept applies in probability also. What is the probability of selecting 6 rows and 6 columns at a time, or this type of questions they might be asked in competitives. So, but like if 4 rows and 6 rows are selected, so what is the probability of getting choices? So, if you know the chessboard very clearly, you'll definitely able to solve these probability questions, and this matrix is also very easy. If you know the matrices, you can apply the concept and some standard rules in chess, and you will definitely learn that. So now coming to the technology. Cryptography. This word is recently getting very much famous because of this cryptocurrency. So for that, to choose algorithms, and again like again in geometry also, geometrical images. We observe in the Excel sheet also, right? Excel sheet. So what is the Excel sheet? In Excel sheet, one like this only, right? In chessboard, it represents chessboard type only. So if you use matrix, so matrix uses like this. So to select the specific target in genetics also, like we are closing here, right? I'm selecting, I'm having boundaries for matrix. So I can select a tissue and I can apply and I can apply genetical engineering in that, and I can modify the tissue. So in genetical engineering and in robotics also, and in virtual reality, augmented reality, deepfake. How we can apply this matrix in deepfake technology? In deepfake technology, the process is face face should be morph, morphing of face is the process in deepfake, right? So for that, every part of the face, it should get morphized. Then only it will, people won't recognize that it is deepfake to image or normal image. For that, matrix, they will use matrices for using algorithms, for using codings, and in defense technology also, to choose the aim of the target, to choose aim of target, because it has horizontal component and vertical component, so it has four sides of boundaries. So you can choose target here. In this way, in technology, matrices are used. In economy, how matrices is useful? In economy, let's take the growth rate of India. India's GDP growth rate. I'm taking sector wise. First, I'm taking agricultural sector. Again, manufacturing. Servicing. There are three types of sectors in Indian economy, right? So I'm taking in this one matrix. I'm taking the growth rate values. Agricultural sector growth rate values, its or GDP. Contribution of sectors of economy. In matrix. How? What is the share of agriculture? What is share of agriculture? It's now it's shown that 15, manufacturing it's 19 to 20, it's 15 to 20. The service sector 50 to 60. So this shows that most of the contribution is made from service sector. So this is how, if we put data in the matrix form, by putting this data in matrix form, we can compare various type of activities in simpler way. Manufacturing contribution is 19 to 20. Again, agricultural sector contribution is 15 to 20. So this means, but again, is this equal to human capital? Human capital ratio, let's see here, how much human power occupied here? About 50. Is this equal? This is not equal, right? This matrix is not equal to, this 15% is not equal to 15. This 20%. Here is how much? Again this 20%. Again 50 to 60. This is 30%. So see the labor occupation ratio here. Here agriculture, this is not matching. So if you take this matrix as A, B and C, So B naught equals to C. So this is how we can represent Indian economy in matrix form. Matrix also helpful to draw the graphs and to find the growth rates of various sectors and to find the graphs or to draw the, and matrices changes its position from one plane to another plane. That means if in the x-axis, if you are taking 3, 4, 5, so this is in this is in positive x direction. So if it changes its direction according to vector, so if in case it comes this way, so it will become negative y direction, right? So this 3 will become minus 3, this 4 will become minus 4, this 5 will become minus 4. So matrix has this type of property also. It can change direction based on its vector position. So it depends on vectors also. Matrix and vectors are interlinked. And again, and to draw the graph of index, to draw the graphs of various indexes, we uses matrix. So this is how in the future matrices are used in all the fields. So okay friends, in the next video I will meet you with another interesting concept. Until then, take care. Bye bye.